Hello students, good morning. My name is Dr. B. Mallikarjun. Currently, I am teaching operating systems. This is the first video of operating system design and implementation. So, operating system, how operating system works, how to design to set the operating system, and how to operating system can be works. That we will see in this video lecture. Operating system is a system software that manages all the resources of the computing device. Operating system acts as an interface between the software and different parts of the computer or the computer hardware. It manages the overall resources and operations of the computer. So, operating system is the mainly interaction between the user and computer hardware that can be encompasses of several input-output devices are connected to the computer. The operating system manages all the input devices and output devices. It controls all the input devices and output devices. How it can be works, then you see in this slide. So, operating system controls and monitors the execution of all other programs that resides in the computer, which also includes application programs and other system software of the computer. Operating system can examples of Windows, Linux, Mac operating system, Android operating system, iOS, etc. It manages application programs, other system software of the computer. So in this figure, how operating system can be designed, that I can show in this figure. This figure gives the external view of user 1, user 2, user 3, and so on, n number of users connected to the layer. That layer is system and application program layer. This system and application program consists of compilers, assemblers, text editors, and database system. There are various applications are connected in this layer. The inner layer of this layer consists of the operating system. The operating system composed of the hardware core. The hardware is the core part of the operating system. Okay, then this is how the layers have been connecting in the operating system. So this is mainly controls the monitor and execution of all other programs as a representation of this diagram. That how operating system, mechanism, and policies. So mechanism is different and policies is different. The combination of mechanism and policy not good. Mechanism determines how to do something. Policies determine what will be done. One important principle is the separation of policy from the mechanism. So the good example and good and flexible is mechanism is different and policy is different in this diagram. This is the example of car driving on the road. So, car driving on the road is an example. The combination of mechanism and principle is not at all good. This is not at all good. So, the differentiate between mechanism is separate and policies is separate. That is a good and flexible connecting things. So, car driving on the road, the driver doesn't know how to work inside the policy. Mission and how the engine works, that and all, the driver doesn't know. But driver knows only the driving. So we are also the users, we can interact with the operating system. We don't know how the hardwares are working inside the computer. We don't know. That's why our working is good and flexible because mechanism is separate and policy is separate. Okay, this mechanism and policy combination is not good for learning. So that's why, but we have to learn the operating system, that is the main mechanism and policy. So that's why the both are different. Hardware is different and software is different. Like mechanism is like to be a hardware and policy is like to be software. Let them combination of both working with the principle of operating system that can understand by the user. The two are different things here. Hardware is different and software is different. So let me see the next slide. The mechanisms and policies of operating system. The main example is the resource allocation. If a process needs a particular resource, it requests for the resource and the resource should be allocated to the processes. If a process has request for the resources, how resource is allocated to processes is its mechanism. When they allocate the resource to the process or not, it's its policy. The main mechanism and principle works with the operating system with the resource allocation. This is the main definition of the operating system. How the resources can be connected to the software. The main resources of the operating systems are input-output unit, control unit, and memory unit. These resources connecting with the hardware and work with the policy. The main policy request for this the resource allocation strategy with the hardware components, whether to allocate the resource to that process or not is its policy. The mainly operating system working with the principle of resource allocation. How the operating system can be implementation. Once if an operating system is designed, it must be implemented. Traditionally, operating system has been written in assembly language. Now they are most commonly written in high-level language such as C and C++. The high-level languages are C and C++ are truly high-level principles. Means the user can understand these two languages, C and C++. So, but how the language can be works inside the hardware, that user doesn't know. Means the machine level language user cannot understand. So that's why the advantages of a higher level language means the code can be written faster. It is more compact. It is easier to understand and debugging. It is easier to portability. Means the executable code can be taken from the one system that can be executed in another system also. So mainly the operating system must be implemented with the high level languages. The users write the programs in the high level language. That is the implementation of the high level language with the works on the operating system. Operating system facilitate the several other softwares like VLC player, like Windows Media Player, like MS Office. Those all are softwares that can run on the system software. System software is a operating system. Operating system mainly works in the system software. So the main examples of operating systems are MS-DOS. It was written in Intel 8088 assembly language. Consequently, it is available only the Intel family of CPUs. This operating system is not flexible to the user. This is old operating system, and this operating system is the root cause of to born all other operating system. MS-DOS operating system, people also call it as the dirty operating system because it can works on command-based operating system. It works on the commands. but not efficient, but not convenient. So Windows is the most convenient operating system. Use of fields and works with that operating system. So Linux operating system is written mostly in C and it is available on number of different CPUs, including Intel 808 x86 family, Motorola 680X0 family. Spark is the one of the Linux operating system. MIPS RX000 is also one of the operating system. This MIPS means million of instructions per second. This operating system comes under the Linux category. So the first Linux operating system born with the Unix operating system. Unix called as UNIX. This Unix people actually it can be termed as UNICX, Uniflex computing system. After number of days gone, it become Unix. This is the first operating system which was born by the C programming language. Then people named it as UNIX. This is the way of operating system born from MS-DOS to Unix operating system. So the main operating system design and principle it is a form of the monolithic structure. The kernel is the internal part of the operating system. The kernel is the main interacted with the hardware. The above part of the kernel, there is a shell. The shell is a command interpreter. Shells and commands, compilers and interpreters and system libraries are outermost layer of the kernel. So the user interacted with the shell. The shell interacted with the kernel. The kernel consists of the kernel interacts with the shell by the system call interface to the kernel. So that shown in this figure. This figure is a monolithic structure. This figure, the kernel consists of the signals and terminals handling character of input-output system, terminal drivers. And also, the kernel contains the file system, swapping block, input-output system, disk and tape drivers. And also, CPU scheduling and page replacement algorithms and demand paging, virtual memory. It contains the kernel. The kernel can be divided as the three parts. The kernel interface to the hardware. This kernel again consists of terminal controllers, terminals, device controllers, disk and tapes, memory controllers, and physical memory. These are three internal structure of the kernel. This totally hardware connected to the terminals by the terminal controllers of the terminal, device controllers and disk tapes and memory controllers of physical memory. These are the hardware of the core part of the operating system. Kernel is the core part of the operating system. The innermost layer of the operating system is a kernel. This kernel surrounded by the above layer is a shell. The mainly shell is a command interpreter. The user write the command. That command can be running on the shell layer. Shell and commands, compilers and interpreters and system libraries are working in this layer. These commands are interacted with the kernel. Kernel is the core part of the operating system. That core part of the operating system, kernel, is interacted with the hardware. That hardware consists of the terminal controllers and device controllers and disk tapes. This is the then memory controllers of the physical memory. This is the innermost layer, the kernel interface to the hardware. This is the innermost layer of the kernel interface to the hardware. The hardware is closely connected to the terminal controllers of the terminals, device controllers of the disk and tapes, and memory controllers of the physical memory. This is the monolithic structure. This is the operating system designed with this concept of the monolithic structure. Okay, students, in this video, I explained about the what is operating system, how operating system can be born, and how operating system can be designed and implementation based on the example of car, how car can be works without knowing the engine, the driver can works with the car, then how the operating system hardware can interact with the user, and how the hardware and connecting to the kernel, and how the kernel can be connecting to the shell shown by this monolithic structure. So these references I referred to define these diagrams and the concept. The book is Abraham Silver Scrapped Galvin of the Operating System Principles and William Stallings of the two references I referred. Okay, students, in this video, you can gain the knowledge of how to define the operating system design and implementation. Thank you, students.
Like, share and subscribe. Hit the bell icon for more updates.